About Hooke's law under vibrations and the waves. So Hooke's law is just a law which states that the extension of the loaded spring is directly proportional to the applied force, provided that the elastic limit is not exceeded. We can represent this formula mathematically by writing this equation. So this equation, F just means, let me put the S. Yeah, so it's F S is equal to negative K X instead of this S. Yeah, K X. So this is the formula which explains Hooke's law. So this is just state this applied force, which is Fs, is directly proportional to what? To this x. This x is the extension we are talking about, and this K here is what? Is the constant, the spring constant. So I was just writing it properly. Yeah. So for example, we have this spring here. So you're going to see that this spring here, somewhere here, that's where the equilibrium is. That's where the object should be, but it has moved from equilibrium to here. So the distance from here to here, this one indicated by x, that's what? That's our displacement in the formula. And another thing which you should know also is the spring force always acts in the opposite direction of displacement. That's why in the formula there is a negative here, because the spring force always acts in the what? In opposite direction, because it's always trying to bring an object to equilibrium. So here, since displacement is acting this direction, the spring force is going to act in that direction, the S. So because of this spring force always acting in the opposite direction and always trying to bring an object to rest, is usually called a restoring force. Yeah. So this is all you need to know about Hooke's law. Let me just give you these definitions in a formal way so that you can write in your books. So next time we'll talk about simple harmonic motion, and we'll try to do some examples. So these are just the diagrams to help you understand. So the first diagram, or let me yeah, so this line indicates the equilibrium. So you're going to find the first diagram. The first diagram shows an object is in equilibrium here. So you're going to find x is equal to 0. And when you go to the second object on a spring, has been compressed, and where you can see the distance there indicated by what? By x. So this is the displacement, and since the displacement was acting to the left, the force was going to where? To the right. We got the last object, which was in tension, which was stressed. You're going to see that the displacement was to the right, and as the result, the force, the restoring force, was acting to the left, so that it bring the object to equilibrium. So the reason we call it the restoring force, it's always trying to bring the object to equilibrium. And at the end, the formula, that's where there is a negative in the formula here, there. So always in the formula, it's going to be force is equal to negative K times what? Times X. Yeah. So this is the end of the topic, guys. See you in the next video.